Uneven cash flows are more difficult to compute than an annuity or just a lump sum. And they basically are going to cover anything that isn't covered in the other two cases. So here's some examples. You're going to receive money over a 3-year period, $400 the first year, $300 the next year, and then $250 the third year. So if you were calculating what this is worth to you, as far as what the future value of it would be, we need an interest rate, which we have 5%. And so I think I'll work this backwards. It's kind of maybe easier to understand. If you're going to get money at the end of the third year worth $250, then there won't be any interest accrued. So it's only going to be worth exactly what it is. So its compounding factor is 1. If you're going to receive $300 at the end of year 2, then by the end of year 3, you're going to earn 1 period of interest. So the money will be worth the $300 plus an additional 5%. The $400 that you receive at the end of the first year can grow through year 2 and year 3. So my compounding factor is 1 plus the interest rate, so 1 plus 5%, 1.05, raised to the power of 2 more years of interest that you can earn. So I take those and I multiply the cash flows times those compounding factors. And then we add them together. So equals the sum of these 3 numbers, 441, 315, and 250. So that group of numbers, 1006. The present value, we could do it the same way. So let me move this down just a little bit. So our discounting factors, now we're bringing it back to the present value. So $400 that you receive at the end of year 1 is going to discount back 1 year. Interest rate's still 5%. So my discounting, if you have watched my other videos, is equal to 1 divided by 1 plus the interest rate, so 1 plus the 5%, raised to the power of the year. When it's only 1, you don't actually have to go through that because it leaves it at the same, but 95% basically. Year 2, 1 divided by 1 plus the interest rate, 1 plus 5%, raised to the power of 2 years of discounting. Year 3, 1 divided by 1.05, raised to 3 years. And then again, we're going to multiply them. So take that 0.95 times the 400. And the present value of the money that you receive at the end of year 1 is $380.95. Copy that formula over. And then I can add those 3 numbers together. So equals SUM sum of these 3 numbers, 869.02. Now we do have a function. We have an NPV, or a net present value function that will work with present value. I have nothing on future value. This is the way you have to calculate. But I can use an NPV value function here. So we're going to go under formulas, financial. I'm going to go down to NPV, select it, put our rate in. So I don't have it referenced, so I'm just going to type it in, 5%. And then the values, you could enter each one in a box and this would grow. But the easiest thing to do is just to capture them all at once. So these are my values, 400, 300, and 250. So it needs to be in a string like that. So you start with the first number, end with the last number, because it knows to discount in that way, and hit an OK. And you get the same answer. Now just a note, let's say that you got $0 in year 2 and then $300 in year 3. You cannot leave out the 0. You have to include it because it has to know that the money that you're getting in year 3 is the third period. So you have to show that 0 in the second period. Okay, so finally, the book will go through what's kind of a makes this kind of a difficult problem. How do I know what my interest rate is if I have this kind of cash flow? I invest $10,000 and I get back this stream of money over 5 years. What interest rate am I earning on my $10,000 investment? And the function for that is actually the internal rate of return. Type that in, which is abbreviated as IRR. So I can go to my functions and look for the IRR function, and it will tell me how to find that interest rate, or it will find it for me. So again, alphabetically, so IRR. And this one, we just capture all of the cash flows. So we start in year 0 and we go through year 5. So I'm just going to highlight all those. I do not have to put a guess in. I hit OK, and it's approximately 11%.